What's up, everybody? In this video, we're going to cover USACO's 2021 January contest at the bronze level. Problem number 3, just stalling. Farmer John has N cows between 1 and 20 of heights A1 through AN. His barn has N stalls with max heights B1 through BN. So whatever N is, that's how many cows we have. We have the same number of stalls. A1 through AN represent the cow's heights. So A1 would be the height of the first cow. A2 would be the height of the second cow. So for example, the first cow could have a height of 4, second cow could have a height of 2. Likewise, we have stalls with heights B1, B2. B1 could have a height of 7 or 8 or whatever. B2 could have a height of 3. So we have a collection of cows given their heights. We have a collection of stalls given their heights. So for example, if B5 equals 17, that's, for example, if the fifth stall is 17, then a cow of height at most 17 can reside in stall 5. How many distinct ways can Farmer John arrange his cows so that each cow is in a different stall and so that the height limit is satisfied for every stall? So we're just trying to figure out how many different ways you can organize the cows. So for example, let's just have a simple example. If I had cows of heights 3, 3, and 3, and stalls of heights 3, 3, and 3, then the first stall could have any one of these 3 cows, which would be 3 options. The second stall would have 2 options left, 2. And the third stall would only have 1 option left. Or you could look at it the other way. The first cow would have 3 options of which stall they could go to. Second cow would have 2 options because one of the stalls would be taken. Third cow would be 1. Either way, it's going to be 3 times 2 times 1, which would be 6. So whether you're trying to pick the cow for the stall or stall for the cow, you're still going to have the same equation essentially as how many options are there for each stall or how many options are there for each cow. Input format. Input arrives from the terminal in standard in. First line contains N. It's here. Second line contains N space separated integers, A1 through AN. Third line contains, that's this, by the way. Third line contains N space separated integers, B1 through BN. Those are the heights of the stalls. All heights and limits are in the range of 1 through 10 to the 9th. Output format. Print output to the terminal standard out. The number of ways Farmer John can place each cow in a different stall such that the height limits is satisfied for each stall. Note that the large size of the output might require the use of a 64-bit integer like a long in C++. This, by the way, is why you need to carefully read all of the instructions. A lot of students skip over the output format because they think they understand what they're supposed to do and they miss this long thing, and then the last 6 test cases don't pass and they can't figure out why. Always read the instructions very carefully. Okay, so sample input, sample output. I've got 4 cows and 4 stalls. My cows are 1, 2, 3, 4. My stalls are 2, 4, 3, and 4. So it says the sample output is 8. In this example, we cannot place the third cow, that's this one, into the first stall, that's this one, since 3 is bigger than 2, right? That makes sense. Similarly, we cannot place the fourth cow, which is this one, in the first or third stalls, that one or that one. One way to satisfy height limits is to assign cow 1 to stall 1, cow 2 to stall 2, cow 3 to stall 3, and cow 4 to stall 4. Okay. So we have 8 possibilities with this. Let's see if we can figure out what 8 they are. All right. So first cow. This cow right here is going to have 4 possibilities for cow 1. Cow 2 is going to have, looks like also 4 possibilities. Cow 3 has 3 possibilities. And cow 4 has 2 possibilities. But if you multiply these numbers together, your answer is going to be too big. You can already tell 4 times 4 is bigger than 8. Reason why that is because whatever stall is taken by the first cow is not available for any other cows. And that's a really important thing to note is there's no replacement on this. So reevaluating this, first cow could go into any stall, but if that cow were to take stall 4, then that's 1 less option for the cow with height 4. Generally speaking, the smallest cow should go into the smallest stall. So if cow 1 was placed into here, that would be 1 option. There's 4 options for cow 1, but we would want the cow to ideally end up in here. Now, the reason why this is going to throw everybody off is because we need to figure out a way to distribute these cows with no replacement, but then also to optimize things. We could say that cow 1 gets placed in stall 2, but that doesn't mean that cow 1 has 1 option. We don't really know how many options cow 1 has until we place the larger cows first. So take a minute to fiddle around with that and see if you can figure out how to approach this problem, and then we'll move on to solving it. I recommend, I mentioned this in all my videos, but I recommend always using paper and pencil and drawing out a couple example cases, play around with it. Another thing that might not hurt is for problems like this, sometimes you can get a piece of paper and write numbers and cut them out of the paper, make little squares with numbers written on them and actually move them around on a desk. that can really help in visualizing these problems. The better you can do to visualize this, you really don't want to be doing these in your head. The more successful students oftentimes are not doing these problems just mentally. They're using props or drawing pictures. That's the best way to get a visualization of the problem. So the first thing you're going to want to do is you're going to want to sort both the cows and the stalls in decreasing order. The reason why is because the larger cows are going to have the fewest options. So you want to analyze them first and make sure that you know how many options they have. Cow 1 has 4 options, maybe, but if we have cow 1 take stall 4, that's going to limit the number of options for cow 4. Whereas if we let cow 4 get placed first into whatever stall cow 4 can fit in, then that's going to maximize the number of options. So then this will become 4, 4, 3, 2. 4, 4, 3, 2. Okay, so looking at this again. Cow of height 4 has 2 options. Cow of height 3 is going to have only 2 options as well. The 3 and whichever 4 is still available after the first cow takes their stall. So we don't need to know exactly what stall they take, but we do need to know the number of options. Cow 3 can only have 2 options because cow 4 will have to have taken one of these 2. Cow of height 2 is going to have also 2 options because again, cow 3 will have taken one of those 2 stalls and cow 4 will have taken one of those 2 stalls. So for example, if cow 4 takes this one and cow 3 takes this one, then cow 2 has 2 options, which would be the 3 and the 2. However, because there are other ways to distribute this, if this cow here took stall 3, then this cow here, cow 2, can take the 4 stall. Or if the first cow took the second 4 stall instead of the first 4 stall, then cow 2 could take that 4 stall. But either way, cow 2 is only going to have 2 options because one stall is going to be taken by cow 4, one stall is going to be taken by cow 3. Finally, you're going to have the cow of height 1. Cow of height 1 is going to have 2 potential options. No, 1 potential option. Cow 2 had 2 options. Cow 1 has 1 option, which is going to be 2 times 2 times 2 times 1, which is 8. And that's the answer. Let's run through that again and kind of see again how that's going to work. So what you want to do is you take your 2 lists, you sort them in decreasing order. Start with the first cow, count through these, and figure out how many stalls they'll fit in. Once you get to a stall they won't fit in, you know how many options you have. That's your first number to multiply. You'll probably want to have some sort of an options variable that starts with a value of 1, so that as you get new numbers, you can just multiply them in. So this would be 1 times 2. The number of options available, I'm going to write available. Available, so we count here, we count 1 stall, we count 2 stalls, that's 2 available stalls. By the time we get to 3, we've found 2 available stalls for that first cow. 2 available stalls means 2 options, so I multiply this by the number of available stalls. But now I got to subtract 1 from my available stalls because one of those stalls has been taken. I now move on to cow of height 3. I want to continue forward from here and see how many options I have. This cow will fit in this one, so we'll move forward again. Cow won't fit in this one. The height 3 cow won't fit here. So we got 1 more available stall because we're adding in this stall. So we have available 2 now times 2, but then that cow will have taken a stall. So it'll be -1 again from available. So available is down to, I'm running out of space here. Available is down to 1 again. 1 stall available. All right, moving on to the next cow, cow 2. We want to press forward from here. That cow will fit in this stall, so we make it to the end of the stall list. Once you reach the end of the stall list, you can't go any further, but that does mean that there's 1 more available stall. That'll bring us to 2. So once again, we can multiply by 2, subtract 1 from the available stall. From cow 2 taking that stall brings us down to 1. We're already at the end here, so the next cow only has 1 option, which is going to be times 1. And now I've got 1 times 2 times 2 times 2 times 1, which is going to be 8. It's not always going to be multiplying by 2. I want to come up with a bigger example. Let's do, I'm going to already sort them in decreasing order, but let's do like from 6. We'll have cows of height 6. We'll have 2 cows of height 6. We'll have a cow of height 5. We'll skip 1 and have cows of 3, 3, and then 2. For stalls, let's do something wacky. Let's have 8, 7, 6, 5, 4, and 3. All right. So let's see what this comes up with. I'm going to switch to a blank tab here so I have some more room. Okay, so at any given time, I want to know how many options I have. options start off as 1. And there's always going to be at least 1. And how many stalls are available? That's going to start at 0. I have a runner going through my cows, and I have a runner going through my my stalls. Generally speaking, by the way, I used a for loop to run through the cows because every cow has to be placed, but I used a while loop to run through my stalls because you don't know how many stalls are going to fit a particular cow. Okay, so let's kind of walk through this. Every time I advance forward, this is the cow that I'm having to place. Every time I advance forward on this list, I'm adding 1 to the number of available stalls for that cow. Because that's the first thing you're trying to do. You're trying to figure out how many stalls will this cow fit into. A cow of height 6 will fit into an 8, a 7, and a 6, but not a 5. So your counter at the bottom is going to start at 8, and it's going to go 8, and then to 7, that's 1 available. To 6, that's 2 available. To 5, that's 3 available. Once you hit 5, that's too small. So we stop there. You're going to want to keep track of that counter. You have some sort of a counter that now would be like at index 3. Keeping track of, maybe this would be, if you want to do like a for loop and a while loop, then this would be like your I variable. This will be your J variable. So right now your J would be equal to 3. Your I would still be equal to 0. Okay, so we've got 3 available stalls for the first cow because that cow could fit in 8, 7, or 6. So options are going to be times 3. Brings us up to 3 total options. Moving on to the next cow. And then because we placed that cow, we got to subtract 1 from our available stalls. So 1 stall has been taken. It could be 8, could be 7, could be 6. Now, just real quick, I want to point this out if this isn't immediately apparent. As I'm going through my cows, part of the reason I sorted these in decreasing order is I'm guaranteed that every future cow I come across is going to be shorter or equal to the cow that I've already checked, which means when I get to this cow and I want to place her, I don't have to recheck these stalls. I already know that the cow will fit in all 3 of those stalls. So these are available options. When I write this 3, these are options that are available that are at least greater than 6. If they're greater than 6, which is this first cow, then that means that every future cow also will be able to fit in them. So these are like kind of wild card stalls that I could use for any of my remaining cows. But I can't use them if the larger cows have taken them. And so that's why we have to subtract 1 every time we use one, is because every time we place a cow in a stall, even though I had 3 available stalls, I'm going to have to take 1 of them to place that first cow, which means that the remaining cows are going to have at least 2 stalls that are greater than 6. And some of those remaining cows may be shorter. Okay, moving on. So we've got 2 available stalls currently because I've just placed my first cow. My total options for how to place are going to be 3 because I've got 3 options. I've got 3 different locations I could place this first stall. In placing this second cow, I check here. J still can't proceed forward because that 5 is still too small. So there are now 2 options remaining for the second cow because the first cow will be either in this one or this one or this one. And as far as I'm concerned, they're all considered equal to each other because any of the cows will fit in them. For example, if I were to have this cow take this stall, then that wouldn't be available. If I have the second cow take that stall, that's no longer available. But whatever stall I take, my remaining stall will be valid for all of the remaining cows because of how I have this in decreasing order. Okay, so that was 2 options available for the second cow, and that's -1 available stall, which means now I have 1 available stall in the wing. And the 1 available stall that I have so far is this 6 stall. I know that this 6 stall will fit anybody, so that's at least 1 stall that's going to be available. I is going to proceed. I is 1, and then I is 2. I'm not really keeping track of my I variable. I'm just going to erase this. I'll just circle as I go. Okay, so cow of height 5. Again, pressing forward with J. This stall will fit. That's 1 more available stall. So that's 2 now available stalls. 6 and 5 will fit all of my remaining cows, potentially, the 5 or any of the others. So J advances. It won't fit 4, so J is going to stop here. My number of, this was 6. My number of available stalls right now for the cow of height 5, which is my third cow, is 2 available stalls, which is 6 and 5. And that's these 2 right here. So that's a multiply by 2, which is going to give me 12. It's going to subtract 1 from my available stalls. I'm now down to 1 available stall. And again, that stall could be the 6 or could be the 5. It depends on where I place this cow. But either 6 or 5 will fit all remaining cows, again, because it's in decreasing order. Let's say like this one got taken, doesn't matter. So this stall would still be available. That's my 1 available stall, for example. All right, moving to the next cow of height 3. that's large enough to fit actually in either of the remaining stalls. So J can proceed here. That's +1 available, +1 available, and then J gets to the end. So this is going to be up to 3 available stalls now. Those 3 stalls are whichever one 5 didn't take, for example, the 6, and then the 4 and the 3. And the rest of these are going to be pretty mechanical. This cow right here is going to go into any one of those 3 stalls. So I'm going to have times 3, which would be 36. This cow will have 2 available stalls because one of those is going to be taken. And again, it doesn't matter which one gets taken. 2 available stalls, so times 2, which is going to be 72. And then the last cow here will always have 1 stall available. And that stall will be whichever one the 3 didn't take, which could be this 3, or could be that 3, or it could actually be the 6, or it could be the 8 potentially, depending on how we distributed those out. I could have put the first cow in the second stall, the second cow in the third stall, third cow in the fourth stall, fourth in the fifth, fifth in the sixth, and the 2 could have gone in the 8. And that's why we're not really differentiating the heights of the stalls and keeping track of them. We're just keeping track of how many stalls are available that could fit every remaining cow. So 72 would have been the answer I got for that one. So just to kind of recap your approach here, read in your 2 lists. Remember to sort them in decreasing order, 4, 3, 2, 1, and 4, 4, 3, 2. Start with the first cow, send a runner over here, see how many stalls that cow can fit into, in this case 2. Multiply some number that starts hopefully at 1 by 2. Subtract 1 from the available stalls, and then move to the next cow. Find out how many of the remaining stalls are available. Here I've got 4 and 3. Multiply by 2 again, subtract 1 from my available stalls, brings me back to 1. Move to the next cow, add that as an available stall. 2 options now. Multiply by 2 again, subtract 1 from the available stalls. Final cow only has 1 times 1, and that's 8. And just a reminder, make sure you use a long data type. If you're in C++ or Java. Python, I don't think you have to worry about it. All your integers will go as large as they need to. But again, this is a really common mistake for people to fail the last, I think, 6 test cases. And the reason why is because in that last example, you notice that I set it up where you can have a lot of multiplication. Because we can have up to 20 cows, let me just real quick. Because we can have up to 20 cows and 20 stalls. In a worst case scenario, if all the cows are height 1, and all the stalls are height 1, however many that is, then my first cow has 20 options, and then 19, and then 18, 17, 16. That's 20 factorial. 20 factorial is very, very big. So you will need a long to hold the data. Alrighty, that's the algorithm. Good luck coding it, and I'll talk to you on the next one.